far beyond the hush of our own world, where Earth's blue fades into the black velvet of space. The universe stretches, ancient, immense, and quietly alive with mystery. Out here, time slows. The mind unwinds. Let it drift now, like stardust on a solar breeze, as we begin to explore some of the strangest and most fascinating truths the cosmos has to offer. There exists, for instance, a place where it rains not water nor snow, but glass, razor sharp and blown sideways by winds reaching over 5,000 miles per hour. This alien tempest howls across the skies of HD 189733b, a distant exoplanet locked in a tight, scorching orbit around its star. Though it lies more than 60 light years from Earth, the Hubble Space Telescope has captured the eerie azure hue of its atmosphere, a deceptive calm hiding chaos beneath. Its deep blue coloration is not from oceans or clouds, but from high concentrations of silicate particles, scattering light as storms shred the sky. Elsewhere in the stillness between galaxies, wander rogue planets, orphans of gravity. These silent nomads drift endlessly through interstellar space, unattached to any star. Some may once have orbited suns like our own before being cast adrift by gravitational upheaval. Others might have formed alone in the dark. Without sunlight, they remain cold and cloaked, but not lifeless. Some theories suggest these worlds could harbor subterranean oceans, warmed from within by radioactive decay or tidal forces. In the silence of space, they carry their secrets with them, lonely but not empty. And there are even stranger tales written in the sky. Consider neutron stars, the collapsed hearts of once mighty suns. Just a teaspoon of their matter weighs around 1 billion tons. These stars are only about 12 miles across, yet they spin with unthinkable speed, some rotating hundreds of times per second. Their magnetic fields are trillions of times stronger than Earth's, and some emit steady pulses of radiation, like celestial lighthouses. These are the pulsars, flickering rhythmically through the cosmic fog, marking time with eerie precision. One, known as PSRJ 1748-2446 AD, rotates 716 times per second, faster than a kitchen blender. Floating not far in relative terms from these compact remnants are cosmic voids, vast stretches of space where there is almost nothing. The Bode's void, for example, spans hundreds of millions of light years, containing far fewer galaxies than expected. It is a profound emptiness, a black lake in the tapestry of stars. How such a gap formed is still unclear. Some theorize it's the result of merging voids, while others wonder if it hints at something more mysterious. In the scale of the cosmos, where galaxies cluster and string along filaments like dewdrops on spider silk, such blank spaces feel unnaturally quiet, almost like pauses in a forgotten song. And yet, not all silence is empty. On the moon Enceladus, one of Saturn's icy satellites, something stirs beneath the frost. Through cracks in its frozen shell, geysers of water and organic compounds burst into space, hinting at a hidden ocean beneath. These plumes, sparkling in Saturn's reflected light, have been studied by NASA's Cassini spacecraft, revealing complex chemistry and warmth. Here, in the shadows of a gas giant, the ingredients for life gather in the dark, not bathed in sunlight, but perhaps warmed by tidal friction and hydrothermal vents. It is a quiet world, whispering possibilities into the void. Light, too, carries mysteries. When astronomers gaze at distant quasars, the ultra-luminous cores of ancient galaxies. They see light that began its journey billions of years ago. These brilliant beacons are powered by supermassive black holes consuming matter at ferocious rates. As gas spirals inward, it heats and radiates, becoming brighter than entire galaxies. And yet, by the time that light reaches Earth, the quasar itself may no longer exist. We are seeing echoes, cosmic ghosts, flickering across time, illuminating what was, not what is. Then there's the strange physics of black holes themselves, those regions where gravity becomes so intense that not even light can escape. The boundary around a black hole is known as the event horizon, beyond which information vanishes. But quantum theory suggests that information cannot be truly destroyed. This has led to one of the greatest puzzles in modern physics, the black hole information paradox. Some speculate that information is somehow preserved at the event horizon, perhaps encoded on its surface like a cosmic hologram. Others propose it leaks out slowly via Hawking radiation. The answer, still uncertain, teeters at the edge of understanding. Meanwhile, above our heads, the universe keeps expanding. This discovery, that space itself is stretching, shocked scientists in the late 20th century. Even more surprising was the realization that this expansion is accelerating, driven by a mysterious force known as dark energy. Making up nearly 70% of the universe, dark energy is invisible, undetectable by any means we have, yet its influence is vast. Galaxies slip farther apart with each passing moment, and the large-scale structure of the cosmos continues to thin. What dark energy truly is remains unknown, a property of space itself, a new field, a misinterpretation of gravity. The silence does not say. Woven through this expanding universe is another unseen thread, dark matter. Unlike ordinary matter, it does not emit, absorb, or reflect light, yet its presence is felt through gravity. Galaxies rotate more quickly than their visible mass can explain, held together by this invisible glue. Clusters of galaxies bend background light in strange ways, another fingerprint of dark matter's influence. Despite decades of study, no one has yet directly observed a dark matter particle. We see its shadows, its tug, its weight, but not its face. And drifting further still, we find the cosmic microwave background, a faint, omnipresent glow left over from the birth of the universe. This relic light, released some 380,000 years after the Big Bang, now fills the sky as a uniform hum in every direction. It is the oldest light we can see, cooled over billions of years to just 2.7 degrees above absolute zero. Within it are tiny fluctuations, like ripples on a cosmic pond, mapping the seeds from which all galaxies and stars would grow. A whisper from the dawn of time, still echoing across the cosmos. Nearer to home, in the quiet of our own solar system, lies a tiny moon that acts like a mirror. Mimas, orbiting Saturn, resembles the Death Star from fiction due to a colossal crater that gouges one side. But this moon hides a secret. Beneath its cratered surface, some scientists now suspect an ocean may slosh, deep and well hidden. A recent analysis of its slight orbital wobble hints that Mimas might not be entirely frozen. If confirmed, this would place it among an elite group of ocean worlds, moons with seas trapped beneath their crusts, possible cradles for alien life. Across the darkness, stars are born in great glowing nurseries. The Orion Nebula, visible as a faint smudge below Orion's belt, is one such region. Within its dusty arms, new stars ignite, their light sculpting the clouds that birthed them. Massive stellar winds carve caverns through the gas, while gravity gathers new clumps to collapse and blaze anew. The nebula, ever shifting, is a painter's sky, swirls of violet and fire, luminous in ultraviolet. From Earth, it is soft and still, but within it is a symphony of formation, a quiet forge shaping tomorrow's suns. Yet for every star that is born, another fades. White dwarfs, the remnants of sun-like stars, cool slowly over eons. In the distant future, they may become black dwarfs, theoretical corpses so cold and dark they emit no light. None yet exist. The universe is not old enough, but one day, far beyond human history, the last of the stars will dim. The cosmos will fall into a deep and quiet night. Even then, particles may still decay, black holes may evaporate, and what remains will be silence. But for now, the stars still sing. Each one is a furnace of fusion, forging elements in its heart. Our own sun, yellow and steady, fuses hydrogen into helium, releasing light and heat. Heavier stars create carbon, oxygen, and iron. When they die in violent supernovae, these elements are scattered across space. The dust from which planets, oceans, and even life emerge. We are, in the truest sense, made of stardust. Every atom of your body was once inside a star. The calcium in your bones, the iron in your blood, the oxygen in your breath, all born in stellar fire. And still, the stars flicker on, gentle beacons in a sea of night. Some pulse with eerie rhythm, like the variable star delta Cephei, a type of Cepheid variable. These stars expand and contract, changing brightness in a reliable cycle. Astronomers use them as standard candles, measuring distances across the void. Through them, the universe reveals its scale, one heartbeat at a time. Beyond those stars, in the depths of interstellar space, float Oort cloud objects, icy remnants from the birth of the solar system. These ancient bodies, too distant to be seen directly, drift in a spherical halo around the sun, waiting. Occasionally, one is nudged inward, becoming a comet. It begins a slow sunward fall, taking thousands, even millions, of years to return. These celestial nomads leave long, glowing tails as they pass, like memories burning across the sky. Somewhere beyond, in a corner of space, untouched by light, a distant galaxy turns. Not all galaxies spiral elegantly. Some are shaped like cigars, like the Edge-on NGC 4565, known as the Needle Galaxy. Others, like Hoag's object, form perfect rings, stars encircling a vacant core. Their symmetry is breathtaking, their rarity mysterious. What gravitational ballet birthed such structure? How many more like them exist, hidden behind dust and distance? And still we drift onward. Among the stars, there are giants, not metaphorically, but truly. Stars so massive, so luminous, that they dwarf our own sun a millionfold. Consider Ui Scuti, a red supergiant nestled in the constellation Scutum. If placed at the center of our solar system, its outer layers would extend beyond the orbit of Jupiter. And yet, despite its size, it's fleeting. Such massive stars burn through their fuel quickly, living fast and dying young. Their final moments are not quiet. They collapse, sometimes becoming neutron stars or black holes, sometimes detonating in spectacular supernovae. But in their final breaths, they scatter the rarest elements, gold, platinum, uranium, into the galaxy, forging riches in fire. These immense stars often reside in clusters, hives of stellar creation. The Tarantula Nebula in the Large Magellanic Cloud is one such nursery. Within its glowing folds lie some of the most massive stars ever discovered, burning with fierce ultraviolet light. They sculpt their surroundings, triggering waves of new star birth. The nebula glows with soft coral and sapphire hues, luminous in Hubble's gaze. From Earth, it is a blur in a satellite galaxy, but up close, it is thunderous, a storm of stars. Not all galactic wonders blaze brightly. Some lie hidden, cloaked in darkness. Infrared telescopes have revealed entire galaxies obscured by dust invisible to optical eyes. These are dusty starburst galaxies, where stars are being born at astonishing rates, hidden behind veils of cosmic soot. Light takes strange paths here, bouncing, bending, absorbed, and re-emitted at different wavelengths. And beyond these lie radio galaxies, quasar hosts, and blazars, entire classes of celestial entities revealed not by sight, but by their whispering signals across the electromagnetic spectrum. The tools we use to see them are, themselves, marvels. The James Webb Space Telescope, unfurling like a golden lotus in the vacuum of space, peers into the earliest epochs of the universe. It sees the first galaxies still coalescing in the cosmic dawn. Light from these fledgling structures has traveled for over 13 billion years. Webb captures it, not as it is, but as it was, starlight frozen in time. In these faint smudges, we glimpse the universe awakening, the first sparks in the darkness. And in that darkness, time itself behaves strangely. Near massive objects like black holes, gravity distorts space-time. This is not metaphor. Time literally ticks slower in deeper gravitational wells, a phenomenon known as gravitational time dilation. If you spent a day near the event horizon of a black hole, decades might pass for someone far away. It's a reminder that time is not fixed, but fluid, shaped by mass and motion. In the vast theater of space, even time can stretch and sigh. Another strange twist of the universe lies in quantum entanglement, a phenomenon Einstein once called spooky action at a distance. When two particles become entangled, the state of one instantly affects the other, no matter how far apart they are. This defies our classical understanding of locality and hints at a deeper layer of reality still barely understood. Some theories even suggest that space-time itself may emerge from quantum entanglement, woven from threads of connection beyond the visible. Yet while physics bends and mysteries deepen, the beauty of space often lies in its stillness. The Lagoon Nebula, for example, swirls serenely in Sagittarius, glowing pink and lavender. Dark dust lanes curl through its heart, dividing luminous gas like rivers through a painted sky. It is a place of birth and reflection, of new stars and ancient clouds. Observing it feels like watching a dream unfold, slow, majestic, eternal. On the edges of known space, galaxies collide. This is not the crash of solid matter, but a tidal intermingling, stars sailing past stars, gas clouds colliding and compressing, sparking new waves of formation. Our own Milky Way is on such a course, destined to merge with the Andromeda Galaxy in several billion years. Already, gravitational interactions are beginning to pull the two giants together. Their eventual union will reshape the night sky, creating a new elliptical galaxy, a luminous merging of homes. Elsewhere, star systems form with peculiar grace. TRAPPIST. One A faint red dwarf just 39 light years away hosts at least 7 rocky planets, 3 of which lie in the habitable zone, where liquid water could exist. These worlds orbit close and tight, all within a space smaller than Mercury's orbit. From the surface of one, the others would loom in the sky like moons, suspended above a crimson sun. Whether they bear atmospheres, oceans, or life is yet unknown, but their architecture alone stirs the imagination, a miniature harmony in the darkness. Still farther, massive clusters of galaxies drift together, bound by mutual gravity. The Virgo cluster, the Coma cluster, the Great Shapley supercluster. These are titanic gatherings of matter, strung along invisible filaments in the cosmic web. Between them lies the intergalactic medium, a thin soup of ions and stray atoms stretching across millions of light years. Though nearly empty, this void carries the faint glow of ancient light, the hum of the universe's earliest stories. And somewhere within that hum, strange signals arrive, fast radio bursts, millisecond flashes of powerful radio waves, blaze from deep space with unknown origins. Some repeat, some do not. They appear in all directions, from all over the sky. Are they neutron stars colliding, magnetars flaring, or something else, still unnamed? Their brevity makes them hard to study, but their energy is immense, more powerful than our sun's output in a year, condensed into a moment. Each is a mystery written in static. Closer to home, the Kuiper Belt extends beyond Neptune, a ring of icy bodies, dwarf planets, and frozen relics. Pluto is its most famous resident, but others like Eris, Makemake, and Haumea dwell there too. These are cold worlds, dimly lit, spinning slowly in the distant cold. Some have moons, atmospheres, or even seasons. New Horizons flyby of Pluto revealed a world far more complex than imagined, with nitrogen glaciers, towering ice mountains, and a hazy blue sky. Beyond the Kuiper Belt lies the hypothetical Oort cloud, a vast sphere of icy fragments that marks the edge of the sun's gravitational influence. This shell may contain trillions of cometary bodies, most of which we will never see. Occasionally, one is disturbed and begins a journey inward, a glowing emissary from the dark. These comets, long period and erratic, are ancient messages, whispering of our solar system's infancy. And beyond that, still perhaps, the heliopause, the boundary where the solar wind gives way to the interstellar medium. Voyager 1, launched in 1977, crossed this frontier in 2012. Now over 14 billion miles from Earth, it drifts in true interstellar space, still sending back data. On board is a golden record etched with sounds and images of Earth, greetings in dozens of languages, music from Bach to Chuck Berry, the laughter of a child, a message in a bottle cast into the cosmic sea. No reply may ever come, but the gesture itself is profound. A planet, a species, daring to speak to the stars. And in the stars, time continues to bloom. Blooming informs both ancient and newborn, each moment unfolding silently across the canvas of space. In the constellation Serpens, a peculiar object pulses with quiet rhythm, the Serpens South Cluster. Here, embedded deep within tendrils of molecular gas, stars are forming by the hundreds. They ignite one by one like candles in a fog. Observed in infrared, the cluster glows with a warm scatter of infant suns, each cradled in its cocoon. This stellar nursery, invisible to our naked eye, thrums with a slow heartbeat of creation. Stars do not form in isolation. They often arise in families, sharing a common origin, born from the same cold cloud. Over time, these siblings drift apart, scattered by gravity and chance. But astronomers can trace their chemical fingerprints, a technique called galactic archaeology. By comparing elements within stars, they uncover lineages, long-lost stellar kin, and the turbulent migrations that shape the Milky Way. Our own sun may have siblings out there still, orbiting quietly in some far-off region of the galaxy, holding pieces of the same beginning. And the galaxy itself turns, a slow, grand rotation. The Milky Way, a barred spiral with arms like trailing smoke, rotates once every 225 to 250 million years. This is called a galactic year. By that measure, dinosaurs roamed Earth just one galactic year ago. Our entire human history, from cave paintings to quantum physics, fits within a mere moment of this cosmic cycle. We ride its spiral, unaware, moving with the stars through a halo of dark matter and ancient light. Above and below the galactic plane drift enigmatic structures, the Fermi bubbles, twin lobes of high-energy gas extending tens of thousands of light years. Discovered by NASA's Fermi Gamma Ray Space Telescope, these bubbles may be remnants of a long-past outburst from the supermassive black hole at the galaxy center. Or perhaps they are the result of stellar winds from billions of stars. Their origins remain uncertain, but their scale is breathtaking. Quiet echoes of forgotten violence, glowing softly in gamma rays. Deep in that galactic heart, nearly 27,000 light years from Earth, lies Sagittarius, a star, a black hole over 4 million times the mass of our sun. Invisible yet immense, it shapes the orbits of nearby stars, bending space like glass. Some of these stars, like S2, dance around it in tight ellipses, completing their orbit in just 16 Earth years. Their precise motion has allowed astronomers to confirm predictions of Einstein's general relativity, including the gravitational redshift, where light loses energy climbing out of deep gravity wells. These experiments, played out across vast cosmic scales, speak in silence of a universe that listens. But not all regions of space are so calm. Some stars exist on the edge of destruction, like the binary systems containing a white dwarf and a companion. In these pairs, matter flows from one star to the other, swirling into an accretion disk. If the white dwarf gathers enough mass, it can ignite in a thermonuclear explosion, a type 1 supernova. These events are so consistent in brightness that they are used as standard candles to measure vast distances. Through them, we learned of the universe's accelerating expansion, a truth encoded in destruction, painted in fire across the sky. Farther still, the mysterious phenomenon of gravitational lensing bends our understanding of space. When a massive object lies between us and something even more distant, its gravity can distort and magnify the background light, like a lens made of space-time itself. Sometimes this creates rings, arcs, or multiple images of the same galaxy. These cosmic lenses reveal galaxies too faint to be seen otherwise. They show us the universe as it was billions of years ago, a deeper, more crowded sky, where galaxies jostled close and stars were born with abandon. And within those distant galaxies are black holes of astonishing size. Some reach tens of billions of solar masses. These ultramassive black holes, like the one in the galaxy TON 618, challenge our understanding. How could such titans grow so quickly, so early in cosmic history? Were they born from direct collapse, fed by unusually dense environments? Their mass warps not just space, but theory, inviting speculation, urging humility. Yet amid all this vastness, the quiet persists. The cosmic background neutrinos, nearly massless particles formed in the first seconds after the Big Bang, still travel through space, nearly undetectable, passing through entire planets as if they weren't there. They are everywhere in vast numbers, yet invisible. A ghost wind from the beginning of time, washing over everything without trace. And washing over us, too, is the zodiacal light, a faint, diffuse glow seen just before sunrise or after sunset, formed by sunlight scattering off interplanetary dust. It stretches upward from the horizon in a slender pyramid, gentle and gray like the breath of the dawn. This dust, drifting between the planets, comes from comets and asteroids, ground down over eons. It is the leftover residue of formation, a soft, shimmering veil that reveals itself only when the world is still. Even Earth is part of this endless drift. Our planet, tilted on its axis, wobbles slowly in a motion called precession, a 26,000-year cycle that shifts the stars of our sky. Polaris will not always be the North Star. In 12,000 years, Vega will take its place. The constellations themselves change, twisted by time, their mythologies reformed. We look up and imagine permanence, but even the heavens evolve, patiently, delicately, beautifully. Our moon, too, is moving. Each year, it drifts about 3.8 centimeters farther from Earth. In the distant future, eclipses will cease to occur as we know them. The moon will no longer perfectly cover the sun. Totality will become a memory, a story told of a time when the sky went dark and stars came out at midday. Even the rhythms we take for granted, tides, shadows, the cycle of light, are impermanent. But in that impermanence is poetry. Comet 67P, a small icy wanderer, emits a curious song, a low-frequency vibration inaudible to human ears, likely caused by oscillating magnetic fields. It is not music in the usual sense, but a pulse, a breath, a murmur. Space, often thought of as silent, has voices, plasma waves, solar flares, the sigh of radio static from Jupiter's auroras, and always the background hum, the residual echo of a universe born in fire, now cooling and quiet. Through these sounds and silences, we piece together a story far older than ourselves, a story still unfolding, a dream without end. And so, as we float deeper into that dream, the stars continue to turn, turning with ancient grace, tracing slow spirals through the abyss. Some spin alone, while others move in concert, locked in celestial dance. Binary stars, two suns orbiting a shared center of mass, are common throughout the galaxy. Sometimes their light blends to appear as one. Other times, they eclipse each other, producing soft, rhythmic dimming visible even from Earth. The Algol system, known as the Demon Star, has flickered since ancient times, its regular dimming once attributed to mythic omens. Now, we know it as an eclipsing binary, a silent interplay of motion and light. Even more complex are trinary and higher order systems, where 3 or more stars orbit in delicate balance. These are gravitational ballets, intricate and precarious, often shaping the fate of their surrounding planets. In some systems, planets loop around just one star. In others, they swing in wide arcs around the entire stellar ensemble. These exotic orbits, sometimes elliptical, sometimes wildly tilted, hint at turbulent beginnings, shaped by collisions, migrations, and the gentle tug of unseen companions. And where stars crowd together, in globular clusters for instance, the night becomes a tapestry of brilliance. On 13, the Great Hercules cluster contains hundreds of thousands of ancient stars packed into a spherical swarm. These clusters are among the oldest structures in the galaxy, their stars glowing with soft amber light. Seen through a telescope, they appear as snow globes of starlight, suspended in the dark. Some orbit far above the galactic plane, relics of a primordial past, whispering of a time before the spiral arms had fully unfurled. These clusters lie near the edge of the galactic halo, a region faint and diffuse, where stars grow sparse and the darkness deepens. Here, stellar streams flow, remnants of dwarf galaxies, long since absorbed by the Milky Way. These ghostly rivers of stars, arcing through the halo, are fossils of galactic evolution. They drift in quiet procession, mapping the gravity of the galaxy, revealing hidden mass, and tracing history written in motion. Beyond our galaxy, others shimmer, each a vast island of stars, gas, and dark matter. The Hubble Ultra-Deep Field, one of the most profound images ever captured, reveals thousands of galaxies in a patch of sky no wider than a grain of sand held at arm's length. Spiral, elliptical, irregular, each one distinct, each one filled with its own stars, its own planets, its own unknowns. The farther we look, the deeper into time we peer. Light from these galaxies began its journey billions of years ago, carrying with it the shape of a younger universe. Some of these galaxies are compact and fiery, others diffuse and dim. Some race away from us at incredible speeds, not through motion, but through the expansion of space itself. As they move, their light stretches, shifting into redder wavelengths. This redshift is a measure of distance, of velocity, and of time. It tells us not only how far they are, but how fast they are retreating. The farther a galaxy, the faster it recedes, an echo of the Big Bang still unfurling. In some corners of the sky, galaxy clusters, like Abel 1689, serve as cosmic magnifying glasses. Their immense gravity bends and magnifies light from galaxies behind them, allowing us to see deeper than ever before. These gravitational lenses produce arcs and rings, distortions of beauty and utility. Through them, we discover faint galaxies at the edge of visibility. The first builders, architects of the early cosmos, crafting the scaffolding upon which everything else would rest. These galaxies, in turn, are built from smaller pieces. In the early universe, tiny proto-galaxies collided and merged, forming the first large structures. This hierarchical assembly continues today. The Milky Way is currently consuming the Sagittarius dwarf galaxy, pulling its stars into long, looping streams. Galactic cannibalism, though slow and silent, is a natural part of cosmic growth, a process by which the universe sculpts itself, one collision at a time. Yet not everything in space is so immense. At the atomic scale, the cosmos holds wonders just as compelling. Hydrogen, the simplest and most abundant element, formed minutes after the Big Bang. It is the fuel for stars, the building block of water, the first note in the chemical symphony. Helium followed, born in the same crucible. Heavier elements, carbon, nitrogen, oxygen, were forged in stellar hearts and scattered by explosions. Gold and uranium, heavier still, came from neutron star mergers, their creation a brief, cataclysmic blaze. These elements combine into molecules, drifting through clouds of gas and dust. Some form simple chains: water, carbon monoxide, ammonia. Others are more complex, like polycyclic aromatic hydrocarbons. These molecules, found in comets and interstellar clouds, may represent the earliest steps toward life. Organic compounds have been detected in the tails of comets, in the rings of Saturn, and on the surface of asteroids. The seeds of biology, it seems, are not confined to Earth. They are scattered like pollen through the galaxy. On Titan, Saturn's largest moon, liquid methane lakes ripple beneath a golden haze. Its surface is sculpted by rain, rivers, and dunes, all made not of water, but hydrocarbons. Here, the chemistry of life unfolds on a different stage, colder and stranger. The Huygens probe, descending through Titan's atmosphere, revealed a world both alien and familiar, with mountains, deltas, and fog. Beneath its icy crust, a subsurface ocean may churn, rich with ammonia and complex chemistry. It is a moon that dreams in cold, a frozen echo of possible life. Europa, too, circles Jupiter, with secrets hidden below. Its fractured surface, etched with red lines and broken plains, is a crust of ice over a deep global ocean. Tidal forces from Jupiter's gravity knead its interior, generating heat, perhaps enough to sustain life. Plumes of water vapor have been observed erupting into space, offering glimpses into the dark sea below. In time, missions like Europa Clipper will peer closer, listening for signs of activity, tasting the ocean's breath. And farther still, in the Kuiper Belt, the New Horizons spacecraft found Arakoth, a contact binary shaped like a flattened snowman. This untouched relic, orbiting quietly at the edge of the solar system, holds clues to the earliest stages of planetary formation. It is not dramatic in appearance, but in stillness lies meaning. Unaltered for billions of years, it is a time capsule from the solar system's youth, a whisper of how it all began. The same quiet persistence is found in planetary rings, thin, radiant structures formed from dust and ice. Saturn's rings are the most majestic, stretching over 170,000 miles, yet rarely thicker than a few dozen feet. They shimmer in sunlight, ever-changing with shadow and perspective. Their origin remains debated. Perhaps they are remnants of a shattered moon or the leftovers of formation. Either way, they are ephemeral, slowly dissipating over millions of years. What appears eternal from Earth is in fact a fleeting sculpture of motion and mass. Across the universe, time unfolds in such quiet paradoxes, fleeting and infinite, delicate and vast. And still the galaxies turn and the light travels on. Onward, weaving through the corridors of space, a silent traveler bearing stories older than language. Each photon, each particle, carries the memory of a distant sun or a collapsing star, of moments that occurred long before Earth had oceans, before our planet spun into being. The universe, vast and inscrutable, writes its history not in pages, but in waves and wavelengths, light redshifted with age, X-rays from accreting black holes, and the faint whispers of the cosmic microwave background. In this vast quiet, gravity becomes the artist. It sculpts galaxies, binds solar systems, and creates elegant shapes like Einstein rings, perfect circles of light formed when a distant galaxy is lensed by an intervening one directly along our line of sight. These rings are rare, delicate phenomena, like dew on a cosmic web, and they serve as natural observatories, magnifying the earliest galaxies so that we might study the first stars. In some corners of the cosmos, entire galaxies glow in eerie isolation. These are ultra-diffuse galaxies, large, ghostly systems with few stars. Some, like Dragonfly 44, are nearly invisible except through the pull of their dark matter halos. These galaxies are paradoxes, large but dim, structured yet sparse. They may be relics of failed formation or remnants of galactic encounters, drifting quietly through clusters, their stars scattered like embers. Even more ethereal are the tidal tails, long streams of stars flung outward during galactic mergers. These stellar trails can extend for hundreds of thousands of light years, curling and looping as if drawn by a painter's brush. They trace the chaos and choreography of galactic interaction, preserving the dynamics of ancient collisions. Though faint, they are some of the most beautiful structures in the night sky, the fingerprints of gravitational embrace. And then there are planetary nebulae, the final breath of sun-like stars. When such stars exhaust their fuel, they shed their outer layers in soft waves of gas, leaving behind a white dwarf, a dense, cooling ember. The expelled material glows under ultraviolet light, forming intricate patterns, hourglasses, rings, butterflies. Each nebula is unique, shaped by magnetic fields, stellar winds, and hidden companions. The cat's eye. Nebula, the helix, the ring, all are moments of stellar farewell, fragile and luminous, fading over time like fireflies. In the quiet between these bright outbursts, brown dwarfs drift, not quite stars, not quite planets. These objects are failed suns, massive enough to glow with faint infrared light, but too small to sustain hydrogen fusion. They exist in liminal space, often invisible to traditional telescopes, scattered throughout the galaxy. Some roam alone, others in hidden orbits around stars. They are cool, dim, and plentiful, the silent wanderers of the stellar hierarchy. And scattered among them are the exoplanets, thousands now cataloged. Some scorch in tight orbits around their stars. Others drift on wide, cold paths. A few lie in the habitable zone, not too hot, not too cold. Planets like Kepler 186f, LHS 1140b, and TOI 700d stir dreams of distant oceans, alien skies, and unfamiliar life. We know little of their surfaces, but their silhouettes, seen in transits, in wobbles, and flickers of starlight, reveal their presence, each one a world unto itself, wrapped in possibility. Some exoplanets are strange beyond imagining. WASP 12b is so close to its star that it is being slowly consumed, its atmosphere stretched into a tail like a comet. Others, like Kepler 16b, orbit two suns and would see twin shadows on their ground. Some are tidally locked, with one side in perpetual daylight and the other in endless night. There are planets where it rains molten iron, where winds scream at thousands of miles per hour, where the skies are colored by chemical storms and unfamiliar suns. And closer still, our own solar system holds mysteries unresolved. Venus, our sister planet, is a place of extremes. Its thick atmosphere traps heat in a runaway greenhouse effect, making its surface hotter than Mercury despite being farther from the sun. Sulfuric acid clouds swirl high above, and its volcanic plains may still be active. Yet in its clouds, 50 kilometers above the surface, temperatures and pressures become Earth-like. Some scientists speculate that microbial life, hardy, acid-tolerant organisms, could survive in that suspended layer. If life exists on Venus, it would be unlike anything we know, thriving in an aerial sea of fire. Mars, too, beckons with questions. Once, it flowed with rivers, carved canyons, and may have hosted lakes or even oceans. Now, its surface is cold and dry, but hints of water remain in polar ice caps and salty brines beneath the surface. Ancient minerals and methane spikes suggest past or present biological activity. Robotic explorers like Perseverance and Curiosity search for these signs, digging through ancient lake beds, listening to the whisper of Martian winds. Each grain of red dust is a letter in the planet's long, silent history. Beneath the icy crust of Enceladus, hydrothermal vents may simmer in the darkness, releasing plumes of water rich with organic molecules. These geysers jet into space, forming Saturn's E-ring and offering a window into the moon's hidden ocean. Cassini flew through these plumes, tasting their composition, capturing hints of complex chemistry. The ocean below is likely salty, likely warm, likely stirred by the tug of Saturn's tides. If life exists beyond Earth, it may dwell here, deep, dark, and undisturbed, thriving in silence. And drifting far beyond all known orbits may lie Planet 9, a hypothetical world whose gravity could explain the peculiar motions of distant objects in the Kuiper Belt. This unseen planet, if it exists, could be as massive as Neptune and orbit hundreds of times farther from the sun than Earth. Its detection would reshape our understanding of the solar system's boundaries. For now, it remains a ghost, hinted at by movement, suggested by numbers, but still cloaked in mystery. At every scale, from the smallest quark to the sweep of superclusters, the universe reveals itself in fragments, some glowing, some shadowed. Our instruments, our minds, our curiosity reach outward like tendrils of light, trying to touch the unreachable. And in return, the cosmos answers, not with clarity, but with wonder. Even now, in laboratories and observatories, scientists ponder new frontiers. Could there be more than one universe? The theory of a multiverse suggests that our cosmos might be just one of many, each with its own laws, its own stars, its own stories. Some may be lifeless, others teeming. Some may be ruled by entirely different physics, where gravity repels and time flows in loops. Though we cannot observe them directly, the mathematics hints at their possibility. A grander stage, still veiled. And in that possibility, the dream deepens like a spiral into velvet dusk, winding through layers of speculation and soft revelation. For even as we map the stars and catalog the orbits of far-flung worlds, the edge of what we know remains wrapped in mist. The universe is not merely a collection of facts, but a well of wonder, always deepening, always distant. In the quiet corners of quantum theory, scientists speak of vacuum fluctuations, tiny, momentary changes in energy that blink into and out of existence. These fluctuations, though fleeting, may have given rise to the entire universe. The idea that all of space and time could emerge from a quantum fluctuation is as unsettling as it is beautiful, that from nothing, everything might arise, not with a bang, but with a shimmer. Some theories suggest that these fluctuations continue, creating baby universes that bud off from our own like bubbles in an infinite sea. If true, then reality is not a single story, but a branching tree of universes, each with its own destiny. In one, the stars may never have formed. In another, gravity may pull outward instead of inward. In still another, perhaps, a version of you looks up at a different sky, pondering questions with a different name. And yet, in all versions, silence reigns. Between galaxies, between atoms, between the tick of one photon and the next, there is stillness. The void is not absence, but canvas, a stage for light and thought, and time to unfold. It is here, in this calm, that gravitational waves ripple. First detected in 2015, these waves are tremors in space-time itself, caused by massive events like colliding black holes or merging neutron stars. They pass through Earth unnoticed by our senses, stretching and compressing reality by less than the width of a proton. But with instruments like LIGO and Virgo, we hear their passage, the low groan of space-time shifting under unimaginable weight. Each detection is a moment of time made audible, a story written not in light, but in motion, a tale of two stars spiraling inward, of their final embrace, of a new black hole born from flame and force. We listen across the void, catching these murmurs, these waves that have traveled for billions of years before reaching us. And still, the Earth turns, carrying us through the cosmos. We orbit our sun at 67,000 miles per hour, while the solar system itself moves through the galaxy at nearly 500,000 miles per hour. The Milky Way, too, speeds through the local group, falling towards a great attractor, a mysterious concentration of mass-pulling galaxies toward it. This journey has no edge, no center. Space itself expands, and everything within it moves. Yet from our small perch on this blue world, the stars appear fixed, their constellations unchanged through a human lifetime. Orion still lifts his arm above the horizon. Cassiopeia still forms her throne. The Pleiades still cluster like a handful of dew. These stars, though hurtling through space, seem still, a gentle illusion, comforting in its familiarity. For countless generations, people have looked up and found their stories in these patterns, tying the night to memory. Above them, the auroras dance, not in space, but born of it. Charged particles from the sun, carried by the solar wind, strike Earth's magnetic field and spiral along its lines to the poles. There, they collide with atmospheric gases, releasing light, green from oxygen, purple from nitrogen. The result is a living curtain, a celestial ripple that shimmers in silence. The northern and southern lights, though shaped by Earth, are gifts from the sun, a reminder of our connection to the stars. The sun itself, steady and golden, is no less complex. Beneath its surface lies a roiling sea of plasma, constantly in motion. Magnetic loops arc into space, releasing flares and coronal mass ejections that can ripple through the solar system, brushing Earth with subtle effects. Its heart is a fusion engine, where hydrogen becomes helium, releasing energy that took hundreds of thousands of years to reach the surface, and just 8 minutes more to reach us. And one day, the sun will change. In 5 billion years, it will swell into a red giant, engulfing Mercury and Venus, and perhaps Earth. its outer layers will drift away, forming a planetary nebula, while its core collapses into a white dwarf. This final phase will last trillions of years, a long, slow fading. Even in death, it will still glow, quietly cooling through eternity. Beyond our sun, other stars have already ended. Some have become neutron stars, compact, spinning beacons that emit regular pulses of radiation. Others have collapsed entirely, becoming black holes. Still others have merged, their light flaring briefly before dimming forever. And among them, some stars go nova, suddenly brightening by a factor of 10,000 or more as a sudden ignition flares and fades. And between these points of light, between all the luminous bodies we can see, lies the dark matter, invisible, untouchable, and yet far more abundant than the matter that makes up stars and planets. We do not know what it is. It may be a new particle or a reflection of some deeper hidden symmetry of the universe, but we see its effects in the way galaxies rotate, in the bending of light, in the web-like scaffolding that shapes the cosmos. This cosmic web, filaments of matter stretched across the universe, connecting clusters of galaxies like threads of silk, reveals the structure of everything. Where the filaments intersect, galaxy clusters form. In the voids between them, there is almost nothing. These voids, like the Eridanus supervoid, are places of strange silence. Some suggest they are anomalies, others natural results of cosmic inflation. Either way, they are immense, tens of millions of light years across, and nearly empty. And still, the silence deepens like a twilight ocean with no shore, where the only movement is the slow unfolding of time itself. These voids, vast and unlit, serve as contrast, framing the luminous structures that span the cosmos. In them, galaxies are sparse, separated by gulfs too wide for even starlight to bridge within a human age. But even emptiness is not truly empty. Within these regions drift stray atoms, lone particles, the occasional dim galaxy, a quiet chorus, barely heard beneath the din of clustered matter. In the deepest of these silences, we find the cosmic background once more, not in light this time, but in neutrinos. These elusive particles, relics from the early universe, pass through everything, billions of them moving through your body each second. They rarely interact, almost ghosts, yet they shape models of cosmology and carry information from the universe's earliest seconds. They are the most abundant matter particles in the cosmos, and among the least understood. Neutrinos, dark matter, dark energy, three great veils still drawn across our understanding. Together, these unseen elements compose the majority of what exists. All the stars, planets, galaxies, and dust that we can see make up less than 5% of the known universe. The rest, the dark, the hidden, we infer by its influence, by the way it tugs on light and matter. It is the gravity we feel but do not see, the expansion we measure but do not grasp, a shadow without a shape. And in that shadow, new ideas take root. Scientists explore the possibility that space and time may not be fundamental but emergent, that they arise from a deeper quantum reality. Some models describe space-time as woven from entangled bits of information, like a hologram, projected from lower dimensional surfaces. If true, then reality as we perceive it, vast, three-dimensional, flowing with time, may be an illusion, a tapestry spun from simpler threads. These concepts are difficult, abstract, and yet oddly poetic. they echo ancient intuitions that the world is not as it seems, that behind appearances lies a deeper order. In modern physics, as in ancient stargazing, we seek unity, a single theory to describe all forces, all particles, all phenomena. String theory, loop quantum gravity, and other frameworks attempt this unification, each offering its own vision of the deep structure of the cosmos. But even as theories evolve, the sky remains constant in its beauty. The Milky Way stretches like a river overhead, its glow soft and complex, made from billions of stars, dust lanes, and distant suns. Within it are wonders yet undiscovered, rogue planets, brown dwarfs, neutron stars too faint to see. Some of these wander the galactic disk, others orbit in the halo, like old thoughts forgotten but not gone. In that disk, the Orion arm cradles our solar system, alongside other stars and their worlds. This arm is not a solid structure, but a region of increased star density, filled with stellar nurseries, open clusters, and gas clouds. It is one of several arms that swirl around the galactic center, creating the graceful spiral shape we know. And the arms themselves move, forming and dispersing over time, shaped by waves of gravity and the movement of stars. Among these stars, our sun is ordinary yet unique. Its stability, its long lifespan, its solitary nature, all contributing to the conditions that allow life to flourish on Earth. Most stars exist in multiples, binary, trinary, or even more complex systems. Solitary stars like the sun are less common, and their steady light creates a more hospitable environment for planets like ours. Whether this configuration is rare or simply one variation among many, we do not yet know. We are only just beginning to understand what life might look like beyond our planet. While Earth is our only example, it may not be the only possibility. Life, at its essence, is about chemistry, energy, and complexity. Wherever those conditions exist, life might arise. On Europa or Enceladus, it may resemble microbes living near ocean vents. On a world orbiting a red dwarf, it might evolve under dim crimson skies. In an atmosphere rich in methane or sulfur, it may breathe elements we find toxic. The possibilities are vast, limited only by nature's imagination. And there may be civilizations too, watchers in the dark, listeners across the void. The search for extraterrestrial intelligence continues with radio telescopes scanning the sky, looking for patterns that do not occur naturally. So far, the silence holds. But even silence can carry meaning. Perhaps we are alone, or perhaps we are early. Perhaps others are too far or too unlike us to be known. Perhaps they too are listening and have only heard the echoes of our own voice. That voice, soft and persistent, has reached space. The radio transmissions of the last century now stretch over 100 light years outward. Voyager's golden record carries greetings in dozens of tongues, the sound of rain, of birdsong, of music. These artifacts, drifting between stars, are our first messages to the cosmos. They may never be found, or perhaps one day, eons hence, something will listen and wonder, and still the stars wheel overhead, each a sun, each with its own story. Some are ancient, some are newborn, some have planets, some burn alone, some will fade quietly, others will end in fire. They move through the galaxy, and we move with them, tracing an orbit that takes hundreds of millions of years to complete. Our place in this spiral is not fixed, but drifting, a quiet voyage through time and space. In that slow drift, the universe continues to unfold. unfold like a flower in endless night, each petal a new revelation, each unfurling an invitation to wonder. There is no hurry in the cosmos, only patience, an infinite calm beneath the restless surface of our thoughts. In the vastness above, we begin to understand how delicately everything is woven, how the rhythm of the stars is echoed in the smallest things. Consider the cosmic rays, high-energy particles that rain upon our planet from distant sources. Some are born in supernova, others in the jets of active galactic nuclei. They travel across the universe, striking Earth's atmosphere and spawning cascades of secondary particles. These silent messengers carry the fingerprints of their origins, offering clues to the most energetic processes in existence. We detect them with great detectors, buried in ice, or stretched across deserts, listening not for light, but for impact. In the cold clarity of the interstellar medium, gas and dust drift in vast, tenuous clouds. Some clouds, like the pillars of creation in the Eagle Nebula, have become icons, immense towers of gas and dust sculpted by stellar winds and radiation. Within them, stars are being born, their light slowly carving away the clouds that cradle them. These are places of beginnings, where hydrogen gathers, compresses, and ignites. The process is slow, measured in millions of years, but each new star is a promise of heat, of light, of orbiting worlds yet to be shaped. Other regions are more obscure, like Bach globules, small, dense pockets of dust and gas that appear as dark smudges against brighter nebulae. These tiny cradles may also harbor star formation, hidden from sight. They are cocoons of future brilliance, wrapped in shadow, waiting. And all around them, the interplay of dust and starlight continues. Dust does not merely block light, it also reflects and scatters it, creating reflection nebulae. Soft blue glows around young stars, like fog lit by lanterns. Even darkness is luminous in the cosmos. The infrared sky, invisible to our eyes, reveals the heat of planets, the birthplaces of stars, the glow of galaxies too distant to see with visible light. In ultraviolet, we see the violence of stellar winds and the fierce energy of young suns. In X-rays, the dance of magnetism and collision. In gamma rays, the footprints of matter and antimatter, of pulsars and annihilation. Each wavelength reveals a different layer of truth, a different chapter in the story. That story reaches far back to the first moments of time, the Planck era, the first sliver of a second after the Big Bang, is still beyond our understanding. In that moment, all forces may have been unified, all matter compressed into a state so dense that the laws of physics as we know them no longer apply. From that seed, the universe expanded rapidly, then slowly, forming the scaffolding for everything to come. Inflation stretched the cosmos, quantum fluctuations, seeded galaxies, and light emerged from the fire. The echoes of that moment remain. The cosmic microwave background carries the imprint of primordial sound waves, pressure ripples in the hot plasma of the early universe. These acoustic peaks, mapped in exquisite detail, tell us about the universe's age, composition, and shape. They tell us it is flat, within a small margin of error, that it will continue to expand, likely forever. That dark energy dominates, though we do not yet know what it is. All of this, from the silence of neutrinos to the roar of galactic collisions, exists in a balance so precise it defies chance. The constants of nature, The speed of light, the strength of gravity, the masses of particles are tuned in such a way that complexity, structure, and life are possible. This fine-tuning has inspired many ideas: multiverse theories, anthropic principles, philosophical reflections. We may never know why the universe is this way, but in the asking, we connect to it more deeply, and in that connection, we continue to explore. Telescopes on Earth grow ever more powerful. Observatories in space drift above our atmosphere, unhindered by clouds or turbulence. The next generation of instruments, the Vera C. Rubin Observatory, the Roman Space Telescope, the extremely large telescope, will peer deeper, wider, and with greater clarity than ever before. They will watch supernovae flicker on distant shores, track the dance of exoplanets, map the structure of the dark universe. Robotic explorers continue their silent journeys. Rovers crawl across Martian plains. Landers sample asteroid regolith. Probes measure solar winds. Each mission is a thread extending our senses outward. In time, we may return to the moon, reach Mars, send sail-powered craft to nearby stars. Human footprints may again mark alien soil, but even then, our true exploration will remain one of mind and heart, the quiet search for understanding. And as we search, the stars keep their vigil. They pulse, rotate, collapse, and reform. They bind and break. They send out light that may never be seen, and they wait for us, for others, for the unfolding of whatever comes next. There is no final destination in this journey, no point at which we will know everything or reach the end of space. The cosmos is not a riddle to be solved, but a mystery to be lived, gently, curiously, endlessly. And so, in the hush of all things, the galaxies turn like slow wheels upon the black canvas of eternity, their motion imperceptible over a human life, yet unfailing across the ages. In this endless drift, stars rise and fall, nebulas bloom and fade, and the light from a million different moments weaves itself into the quiet shimmer of the night sky. Every photon that finds its way to Earth has crossed unfathomable distances, whispering stories from across time. And among these whispers are ancient lights still making their journey. Some, perhaps, began their path long before our solar system existed, emitted by stars that have long since died, their bodies scattered into the interstellar medium. Their light is the only surviving echo, a luminous signature drifting ever outward. When we look up, we do not see the present. We see a sky filled with memory. The deeper we gaze, the further back in time we go. That time, in cosmic terms, is fluid. The early universe was hot and dense, a soup of particles moving at relativistic speeds. But as it expanded, it cooled, and structure emerged. Hydrogen formed, then helium. Clouds gathered, gravity took hold. From this backdrop, the first stars ignited, population 3 stars, massive and short-lived, seeding the cosmos with heavier elements. None remain today, at least none we have yet found. But their presence is inferred, written in the chemical fingerprints of ancient galaxies. These ancient stars may have lit the first galaxies, faint and primitive by modern standards, yet monumental in consequence. They reionize the universe, transforming it from opaque to transparent, allowing light to move freely. The James Webb Space Telescope now glimpses some of these earliest systems, their light stretched by time into the infrared. These glimpses are dim and distant, but profound. In them, we see the universe waking from darkness. And as it wakes, it organizes. Galaxies form along filaments of dark matter, collecting into clusters, then superclusters. Each structure feeds the next, forming a nested hierarchy that extends as far as we can measure. The Laniakea supercluster, which contains our Milky Way, is part of this vast architecture. Its name means immeasurable heaven, and it stretches over 500 million light years. A gravitational basin where galaxies flow like water, pulled towards the enigmatic region known as the Great Attractor. The Great Attractor itself is invisible, not because it hides, but because it lies behind the dense plane of the Milky Way in what astronomers call the zone of avoidance. Yet its influence is felt. Galaxies move toward it at tremendous speed, caught in its gravitational pull. What lies at its core is not entirely clear. A massive cluster, a deeper structure still? The answers are buried in a direction our telescopes struggle to see. A quiet pull felt but not fully understood. In this way, much of the cosmos remains hidden, not by choice, but by nature. Dust, distance, and the limits of our perception obscure large portions of the sky. But with every new tool, every new method, more is revealed. Infrared light pierces dust. Gravitational waves bypass all matter. Neutrinos ignore nearly everything. Slowly, a fuller picture emerges, each layer bringing clarity and complexity. Even our own sun, so familiar and warm, is filled with secrets. Heliosismology, the study of sound waves within the sun, reveals its interior structure. These waves, bouncing through plasma, inform us of flows and layers deep beneath the surface. They show us convection currents, magnetic fields, rotation rates. Our star, it turns out, sings, a deep, resonant vibration far below the threshold of human hearing, a lullaby of hydrogen and helium pulsing with the rhythm of fusion. Other stars sing too. Asteroismology listens to their oscillations, mapping their interiors with extraordinary precision. Red giants, white dwarfs, main sequence stars, each has its own voice, a fingerprint of frequency. These stellar songs tell us of their age, their mass, their core conditions. Even without visiting them, we can hear their hearts beat. And still, Earth spins beneath it all, turning gently, carrying us through light and shadow. The night follows the day, and the stars return. We watch their passage, not only with instruments, but with wonder. In remote deserts, mountaintops, and the stillness of winter skies, stargazers look upward, catching constellations they have seen since childhood, or for the very first time. These familiar shapes, the scorpion, the swan, the hunter, connect us across time and culture. They are our first maps, drawn in light. But the stars themselves do not follow these lines. They move in great arcs, changing slowly over tens of thousands of years. The constellations we know are temporary arrangements, like eddies in a stream. In the far future, Orion will stretch and skew. The Big Dipper will droop. The Southern Cross will tilt. But always, new patterns will emerge, and new stories will be told. And in those stories, we find ourselves tiny, momentary beings on a pale blue dot, floating through an endless night. Yet even in our smallness, we carry the universe within. The atoms in our bodies were forged in stars. The water we drink may be older than the sun. Our thoughts, our dreams, are shaped by the gravity of the earth and the light of distant suns. The universe is not elsewhere. It is here. It is us. And it goes on onward without pause, like a slow breath drawn over eons, filling the silence with meaning, even when none is spoken. For in every speck of dust, in every ripple of light, in every faint vibration through space-time, the cosmos writes a quiet testament to its own unfolding. It does not need to rush. There is no end it seeks. It simply becomes, moment by moment, forever expanding into itself. Even the most fleeting of phenomena take their time in this grand expanse. A gamma ray burst, one of the most violent explosions in the universe, may last mere seconds, but its cause, the collapse of a massive star or the merger of neutron stars, is written across millions of years. These brilliant flashes release more energy in a heartbeat than our sun will in its entire lifetime. And yet, they vanish quickly, leaving only afterglow and memory. Their light travels across the dark, a brief blaze from a far-off past. We are just beginning to capture such moments, thanks to networks of telescopes and sensors that watch the sky constantly. When one is detected, observatories around the world pivot to catch the fading light. Each one is a glimpse into rare physics, the formation of black holes, the creation of heavy elements, the dance of compact objects spinning at the threshold of understanding. Even more elusive are blazars, galaxies with supermassive black holes whose jets are pointed directly at us. These jets, launched by magnetic fields wrapped around accretion disks, shine with high-energy radiation that pulses unpredictably. They are lighthouses of chaos, flickering with the breath of the beast at the galaxy's heart. Their light, too, traverses billions of years before brushing against our detectors, their signal dimmed by distance, but amplified by sheer power. Far from these violent centers, planetary systems continue to emerge. Disks of gas and dust encircle young stars, slowly coalescing into worlds. Pebbles become rocks, rocks become planetesimals, and some of these gather enough mass to become planets. Gaps in the disks hint at new worlds carving their paths. Some systems form gas giants close to their suns, hot Jupiters with years that last mere days. Others host rocky planets in wide orbits, in cool, temperate zones. And around these stars, moons may form, some of them large enough to host their own atmospheres, tides, or even subsurface oceans. The idea of habitable exomoons, rich with chemistry and warmth, is a growing frontier in astronomy. They are harder to detect than planets, but simulations suggest they may be abundant, entire miniature systems, orbiting planets that themselves orbit stars, each one a microcosm, a cradle of possibility. Among the oldest known planetary systems is PSRB 1257+12, orbiting not a sun-like star, but a pulsar. These planets, the first discovered outside our solar system, were born from a cataclysm, a supernova that left behind a rapidly spinning neutron star. That planets could form or survive in such a hostile environment is astonishing. Yet they do, circling their pulsar with clockwork regularity, bathed not in sunlight, but in the steady ticking of radiation. The resilience of matter, its ability to organize into complexity despite chaos, is one of the universe's most elegant features. From quarks to galaxies, from dust to DNA, structure emerges again and again, seemingly compelled by the laws of nature to take form, to bind, to become. Life, too, is part of this continuity, not separate from the universe, but a deep expression of it, an arrangement of atoms capable of reflection, emotion, and awareness. Here on Earth, it has taken forms too numerous to count, shaped by ocean currents, mountain ranges, and shifting skies. And beyond Earth, the search continues, quiet and steady. Telescopes now look not just for worlds, but for biosignatures, the spectral hints of oxygen, methane, or other markers in alien atmospheres. Future missions may find such signs, or they may reveal strange chemistries, unlike anything seen here. Either way, each discovery will be a thread woven into the great story, another note in the long, slow music of becoming. And through it all, Earth continues to spin. Clouds form and dissipate. Seasons pass. Glaciers grow and melt. Tectonic plates drift across the mantle's slow churn. Under our feet, the planet hums, a low vibration, a resonance of wind, water, and rock. And above, auroras flicker, satellites glide, and the moon pulls at the oceans, setting tides in motion. The moon, too, carries history. Its surface is marked by impacts billions of years old, its craters untouched by weather or erosion. It is a relic of formation, likely born from a colossal collision between Earth and a Mars-sized body. That impact reshaped both worlds, creating a satellite that would stabilize Earth's tilt, influence its tides, and fill its myths. And even in that myth, there is meaning. For the stories we tell about the stars are as old as language, carved in stone, passed down in song, whispered into the night by firelight. They are our first science, our first art, our way of weaving human time into the deep fabric of the cosmos. We have always looked up, we have always wondered, and so we drift onward, not toward an end, but deeper into knowing. That stretches not toward completion, but toward greater intimacy with the unknown. For the universe does not demand answers. It invites awareness. It does not insist on certainty. It offers mystery, 1,000 quiet questions wrapped in the shimmer of stars and the shadow of nebulae. And as we float through this vastness, we come to understand, to witness, is to belong. Belonging, in the cosmic sense, is not about place, but about presence. We are made of the same elements that swirl in distant galaxies, shaped by the same forces that mold the structure of space and time. The calcium in our bones once glowed in a dying star. The oxygen we breathe was forged in fusion. The hydrogen in our cells has existed since the dawn of time. We are not observers of the universe. We are its expression, a way for it to become aware of itself. And in that awareness, the smallest details begin to matter. A single grain of interstellar dust, for instance, can travel across light years, caught in the drift between stars. These particles are the seeds of new worlds, rich in carbon and silicates, sometimes coated in ices of water, methanol, or ammonia. When these grains gather in a protoplanetary disk, they begin the slow work of building structure, planet cores, moonlets, asteroid belts, a universe built on dust, moving in silence. Some of these particles become comets, icy travelers from the outer reaches of the solar system. When they approach the sun, they sublimate, releasing gas and dust in long, glowing tails. These tails always point away from the sun, shaped by solar wind and radiation. Comets are among the oldest bodies in the solar system, their interiors pristine, untouched since their formation. Each one carries with it a record of the early solar nebula, a time capsule from the birth of our planetary home. And occasionally, these comets fall inward. Some are captured, some are torn apart, others strike planets, leaving behind craters or delivering water and organic molecules. Earth's oceans may owe part of their existence to such collisions. Life, perhaps too. The idea that comets could have seeded Earth with the building blocks of biology is known as panspermia, speculative but compelling. That life's ingredients may fall from the sky, drifting through space like pollen, waiting for fertile ground. Even now, meteoroids enter Earth's atmosphere daily, streaks of light across the night sky, burning brief and bright. Some survive the journey and fall to the surface as meteorites. These space rocks, when studied, reveal clues to the solar system's age, composition, and chemical evolution. Some contain amino acids, the simple molecules from which proteins are built. Life may be rare, but the ingredients for life, it seems, are everywhere. And that life, fragile, adaptable, curious, listens. We place radio telescopes in remote deserts and mountaintops, shielded from interference. We build arrays that scan wide swaths of the sky, listening for patterns, pulses, or anomalies. Projects like SETI and Breakthrough Listen have searched for decades, not yet detecting a definitive signal, but always refining the art of listening. For even the act of listening shapes us. It expands our awareness, grounds us in patience. And in our listening, we also speak. Through math, music, and image, we send messages into space, pulses of prime numbers, maps of our solar system, diagrams of DNA, the golden record aboard Voyager, a copper disc of greeting, music, and nature sounds, carries the essence of Earth to the stars. Should it be found, it will be by someone or something unimaginably distant, not just in space, but in time. A message not to neighbors, but to the deep future. And all around us, that future unfolds. The sun will one day exhaust its fuel, becoming first a red giant, then a white dwarf. Earth will not remain as it is. The continents will shift, the atmosphere will change, life may adapt, migrate, or fade. But long after humans are gone, our cities worn away, our languages forgotten, the light from our planet, the reflection of our oceans and clouds, will continue its outward journey, a pale signal amid the stars. And still the stars are born, in distant galaxies, in dusty nebulae, in clusters that will eventually drift apart, stars that will live for billions of years, stars that will die in seconds, each one an experiment in time. Around them, planets form, perhaps with their own oceans, their own winds, their own watchers. The cycle repeats over and over, not identical but familiar, a quiet rhythm of light and gravity. There is no map that can contain it all, no theory that can fully explain it. The universe resists finality. It offers instead a slow unfolding, like petals in space, like music with no final chord. It asks not that we solve it, but that we feel it, that we witness it, gently and without rush. And so we drift still, wrapped in the light of ancient stars, listening, always listening to the deep, layered quiet that surrounds us, the hush between pulses of radiation, the breathless pause in the long arc of orbits, the calm between creation and collapse. For in this silence, there is an intimacy unlike any other. The silence of space is not absence. It is presence in its purest form, the universe simply being. And in that being, all things continue. The Milky Way, like a grand, unhurried spiral, rotates gently, its arms weaving past each other over hundreds of millions of years. Our solar system orbits the galaxy's center at a stately pace, drawn by the gravity of stars and dark matter alike. We've made this loop less than 24 times since Earth formed. The galaxy changes slowly, but never ceases. It grows by merging. It breathes in starlight. It sends out new worlds into the dark. Among the stars, interstellar clouds swirl, tenuous collections of gas and dust so vast they contain the potential for countless suns. In places, they are ionized by nearby stars, glowing softly in pinks and reds. In others, they lie cold and dark, opaque even to infrared eyes, hiding what lies within. These dark nebulae, like the coal sack or the horsehead, are voids of light only because they are thick with promise. Within them, stars form in secret, slowly gathering from the chaos. Some regions, like the Rosette Nebula or the Trifid, bloom with both dust and fire. They are not static. They are sculpted constantly by winds, radiation, and gravity. What appears as a serene photograph is a moment in a long transformation. Gas eroding, stars igniting, space itself reshaping under unseen hands. Even in their stillness, these clouds move, breathe, and build. And from their centers, light eventually escapes. The light of newborn stars breaking through the gloom, often with jets that shoot into space at incredible speeds. These are Herbig Haro objects, glowing from the shock of outflows, colliding with surrounding material. They last only briefly in cosmic terms, but in that moment, they signal the arrival of something new, a star taking its first breath. The life cycle of stars is a circle drawn across aeons, from dense clouds to protostars, to main sequence suns like our own, to giants and remnants. The end of one star seeds the beginning of another. Supernovae spread heavy elements across space. White dwarfs cool into silence. Neutron stars spin like cosmic clocks, slowing as they radiate energy. Black holes sit in silence, invisible unless fed, waiting in the dark for the fall of mass, the twist of light. And orbiting many of these stars are planets, each with its own character. Some are tidally locked, with one face forever bathed in daylight and the other in darkness. On such worlds, narrow bands of twilight may host temperate zones, a belt of dusk encircling the globe. Others are tilted like Earth, giving them seasons. Still others wobble chaotically, their climates unpredictable, their skies strange. Atmospheres come in endless variation. Some are thick with hydrogen and methane, cloaking the surface in swirling gases. Others are razor thin, barely clinging to the planet. Some are rich in carbon dioxide, in ammonia, in sulfuric haze. Some may have no air at all. And above these atmospheres, skies may be orange, red, indigo, or violet, painted by alien suns, reflected from unfamiliar oceans. Oceans, too, may be strange. Not always water, sometimes methane, as on Titan, sometimes lava on hot volcanic super-Earths, perhaps even oceans of liquid hydrogen or helium on distant gas giants, each one shaped by pressure, temperature, gravity, and chemistry. And beneath their surfaces, currents may stir, tides may rise, and somewhere, perhaps, something may swim. And what of light? What do these skies look like under twin suns or beside a giant ringed planet? What shadows are cast on a world with 5 moons or beneath auroras that span the entire sky? What dreams might rise in minds that evolve there, shaped by different constellations, different days? Such questions cannot yet be answered, but they can be felt, not through certainty, but through the calm curiosity that keeps our eyes turned upward. It is the same wonder that first lifted telescopes to the sky, that guided spacecraft to the edge of the solar system, that still builds machines to catch the faintest light. It is the oldest part of us, the part that wonders and waits. And so we go on, inching ever outward. Our robots land on comets and touch asteroids. Our satellites orbit the sun in graceful paths. Our telescopes peer back to the first galaxies. Each year brings more data, more knowledge. And yet the mystery only grows deeper, more inviting. Not as a problem to be solved, but as a journey to be shared. And in that journey, we are never truly still. Even here, even now, Earth moves. We ride its rotation, its orbit, its gentle drift through the Milky Way. Our atoms vibrate, our hearts beat, our thoughts turn like the planets, slowly, endlessly, always circling. And above it all, the stars continue to shine with quiet persistence, casting their ancient light across the black stillness of space. Each one a beacon, a memory, a distant hearth burning in the cold. Their radiance is not loud. It is soft, patient, a glow that does not call attention to itself, yet cannot be ignored. For the light of the stars is not merely illumination, it is time made visible. Some stars shine for billions of years, gently burning through hydrogen in peaceful fusion. Others blaze hot and short, exhausting their fuel quickly in a burst of energy before fading or exploding. But in their differences, there is harmony. The universe needs both, the long-lived and the fleeting, the giants and the dwarfs. Together they populate galaxies, enrich the interstellar medium, shape the rhythm of stellar generations. And between the stars, the void stretches vast and calm. This interstellar space is not entirely empty. It is filled with tenuous gas, with drifting dust, with cosmic rays and magnetic fields. But compared to the density of even the thinnest air on Earth, it is emptiness, a near-perfect vacuum. It is here that our spacecraft travel, propelled by ancient momentum, their signals returning ever fainter, their journeys never ending. Voyager 1, the farthest human-made object, continues to sail outward through this space, more than 14 billion miles from home. Its instruments, though aging, still send back whispers of data. It measures the particle winds of interstellar space. It listens to the low-frequency hum of charged particles. And it carries, on board, the golden record, that symbolic gift to the stars, etched with Earth's music, greetings, and hopes. It is a lonely path, but not without purpose. In its quiet flight, Voyager teaches us what lies beyond the solar wind, beyond the influence of the sun. It reminds us that our home is not bounded by the orbits of planets, but extends outward as far as our reach can go, and perhaps further still. For beyond the edge of our system, beyond even the distant Kuiper belt, lies the Oort cloud, a spherical shell of icy bodies, comets waiting in the dark. No spacecraft has yet reached this realm. It remains theoretical, inferred from the long, looping orbits of comets that fall inward. But it may contain trillions of objects, drifting in the cold, orbiting slowly over millions of years. It marks the furthest edge of the sun's gravitational touch, the borderland between star and interstellar night. And beyond that edge, other stars, other suns, each with their own unseen Oort clouds, their own planets, their own silent travelers. Some are near, Alpha Centauri, Proxima, Barnard's star. Others lie far beyond, their light faint, their motions barely perceptible. Yet all are part of the same web, the same cosmic structure, tied together by gravity and the long sweep of time. In some regions, stars cluster close, like in the heart of globular clusters, or in dwarf galaxies, orbiting larger ones. In others, they are isolated, alone for light years in all directions. But even the loneliest star shares the same elements, the same physics, the same story. They are kin, scattered across an unfathomable distance, flickering with variations on a single theme. And always, that theme returns to light. Photons streaming outward in perfect silence, bearing energy and information, transforming whatever they touch. Light from a star may warm a distant world, illuminate a moon, or be captured by the mirror of a telescope centuries later. It travels without haste, but also without end, until it meets something or someone who can receive it. Here on Earth, we receive that light in many ways, through our telescopes, through our instruments, but also through our eyes, our thoughts, our dreams. We imagine what it might be like to walk on other worlds, to watch the sun rise on an alien sea, to breathe an unfamiliar air under a violet sky.